as k-array relation. The property whose domain is a set of k tuples is called a relation. Normally, it's called a relation of or k-array relation or k-array relation on A. Okay. So if the predicate, as I said, it has k arguments in the domain, then it is known as k-array relation. Now, if there is two arguments that can be put as a domain, then it is known as a binary relation. And we represent binary relation in a form of, say, infix notation. We don't use the prefix notation. There is a special kind of relationship that we talked about in the last class, that is equivalence relation. That is equivalence relation. And before talking about the equivalence relation, there is something that has been mentioned in this one, that is a predicate relationship that is shown as a picture. As I discussed in the previous class, that we can have two forms for proving the relationship. And what are these forms? One way we can calculate the function and show the output, and another one is we can create a table. In our previous mathematics problem in higher mathematics of HSC, we have done we have or HSC, not HSC, not SSC. Higher mathematics of SSC, we have solved the problems related to functions, just calculating the values. Now we are doing. We are showing here mostly in the higher mathematics of SSC. We have done it using the calculation, but now we are going with, like, our value range has changed because we are now, our value range is some word type terms. That's why we are preferring the table representation for any function. So the function here is bits. Bits, what bits? Scissor bits, scissor, paper bits, paper, or stone bits, stone, or stone bits, scissor, stone bits, paper, like that. So this is how the relationship is represented. So remember one thing which I always forget. That's why I am asking you to remember this thing. That is, whenever a relationship you are placing at this place, and you have two values in the column and the row. So what you have to do is, this portion comes first and this portion comes in the second place. So if the bits relationship is a binary relationship and we want to uh, prove it in terms of this value, so what is this? Scissors are beating scissors. It is not that scissors are beating scissors or paper beating scissors. It is not like that. If you see in that sense, you will see that it is not proving the logic. So if you take this portion first and this one second in the second place, then it will prove your logic, or it will prove the relationship also. So scissors are beating scissors, it is false. Scissors are beating paper, it is true. But if you came in the reverse way, that paper is beating scissors, it is not true, it is false. So this part you should be counting first, and then this part relationship, and this part. So scissor beats scissor, paper beats paper, paper beats scissor, and stone beats scissor. So this is the relationship, how you are going to count it as. Now there is a special kind of relationship, that is equivalence, which is represented, which is a binary relationship. A binary relationship is the equivalent relationship if some features of it are equal. Some features of it are equal. So it tries to capture the essence of equality. Equivalence relation actually tries to capture the essence of equality. And now what is equal? So some examples are given, and these examples are given in terms of this. So equal means like,
Ma'am, ma'am, can you talk a little bit louder because the voice is coming very slowly?
okay, So as I was saying, now is it clear?
Yes, ma'am.
Okay. So equality means like this, 3 equal to 3. So this is equality. So if we think these two values as equal, so what should be used? What should be our task? It is going to be according to the reflexive, symmetric, and transitive property. So a relationship is reflexive. That is, this relationship is reflexive. We want to talk about the relationship, and the relationship is this equivalence relation. And what is this equivalence relation? You can see that two this relationship will have two equal values if they are like this. X is equal to x. So 3 is equal to 3. And it will be symmetric if 3 is equal to 3. And then we also write 3 is equal to 3. So we don't know which one is the y1 or which one is the x1 in that case. And after that, we have seen transitive relationship where there will be 3 equal to 3 and then there will be again 3 equal to 3. So this first 3 will be equal to the last 3. So this is what equal relationship is. This is how you find out the equal relationship. So we imply this equivalence relationship using the mod relation where we have used certain values because we said some features, not all the values will be same. There will be some values which are going to be same. So 10 mod 3 and 10 mod 3 is equal to 1 and 1. So this is implying the x equal to x relationship. It is implying the x equal to x or x are x relationship. This one is x equal to y relationship. You can see that 10 mod 3 and 7 mod 3, we can consider this as 7. So consider this as y. X is equal to y. So if we place y before in the first place and x comes in the second place, so it can be also considered, it is also true. So what is this, what is this part? It is symmetricness. It is the symmetric part where we have x is equal to y and also y is equal to x. This both of these things are true. In the next part we have x is equal to y and y is equal to z. We have just changed the first value here and it will imply, it means that 10 mod 3, it implies that 10 mod 3 is, oh, that I have already written. So x is equal to y and y is equal to z, it will imply that x is also equal to z. That means 10 mod 3 is equal to 13 mod 3. So we have discussed this thing and we had started graphs in the previous class. So that is also going to be needed in this course. So graph is a set of nodes which are connected through some lines. Graph is a set of points, we can say set of points that are connected through some lines. What are these points called? These points are called nodes or vertices, and the lines that are connecting two points, that is known as edges. Graph is a set of points and these points are connected with some lines. So these points are known as nodes or vertices and their connected lines are known as edges. So if we want to represent a graph G is represented as a set of its number of vertices and the number of edges in that graph. So if we consider this graph, the example here given is 1, 2, 3, 4, 5. These are the vertices of that graph B, and E is the number E represents the edges. So what are the edges? 1, 2, 2, 3, 3, 4, 4, 5, and 5, 1 are the edges that is represented within this curly braces, and all of them together are put inside the first brace. Okay, so this is one thing, and another thing is degree. Degree is number of edges on a node. Degree is number of edges on a node. So the edge the vertex 1 or node 1 has two edges coming from it, or you can say as there is no direction of that node, so there it can be said that there are two edges going inside that node also. We can say that. So basically, the number of edges on a node is known as its degree. So the degree of 1 is 2, the degree of 3 is also 2, and similarly for this one, the degree of 1 is 3, 2 is 3, and 4 is 3, and 3 is 3 also. Okay, so this is degree. Now last day we were stuck in self loop. Last day we were stuck in self loop. Self loop, as I said, that if the starting node and ending node of a particular edge is same, starting node and ending node of a particular edge is same, then it is known as self loop. Starting node and ending node is same. So the edge, this one, the round edge here, you may consider these green portions are the nodes. The green and this blue points are the nodes, and this ring here, the format of this ring is known as self loop. So this is an edge which is starting and ending at node 1. There is another self loop that is starting and ending at node 2, and this edge is also starting and ending at node 4, and this is as 3. There are several other edges also, but in this case the self loop is represented in this format where it will be start and end at the same node. Okay, so this was everything about in the previous class. Now there is one more thing, new thing. There are many other new things. One is subgraph. So we have seen subset. Is there any problem? When we have learned set, we have seen. So do you remember what is subset? Can anyone tell me? Say A and B are two sets. How can be a subset of B? How it will be possible?
Ma'am, if all the element of A is same as all the element of B, then we call A is subset of B.
Actually, the thing is not same as it says that if all the elements of A are present in the set B, then A is a subset of B. They can be equal, but the thing is not always subsets are equal. So this 1, 2 is a subset of this one. If I take it as an example, 1, 2 is a subset of this 1, 2, 3, 4, 5, because the elements of this set 1, 2 is present in this set. So this is known as a subset. Likewise, a subgraph is a graph that where the elements of the graph are present in another graph. So if we consider H, the entire thing as a subgraph, I don't know if you can see it or not. There are many lines that are darkened. Some portions, some edges are darker than the usual one. Can you see that? Can you see the darker portion here?
Yes, ma'am.
Has my internet gone? Can you see it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so these darker lines are showing the subgraph of graph A. So the entire picture is the graph. Now we want to show the subgraph. We can also take it away from here, or we can also draw it separately just to show that it can be considered as a subgraph. Where from this node there is one node coming up, another node is here coming, and this can be considered as a subgraph. It is following the property of subset, as it is similar as subset. That's why I have brought the definition of subset here. Okay, so subgraph is a graph where all the nodes and edges of that graph is present in another graph. Now next thing is labeled graph. Next thing is labeled graph. So if we see this picture, we can see the nodes are named with the name of some city. Nodes are named with the name of some city, and previously whatever we have seen that the edges don't have any number assigned to it. Edges don't have any number assigned to it. So what are the edges here? The edges have some values. So as you can see that from New York to Boston there is a value assigned. So we can consider this value as the distance between them. But the point here is if the edges of any graph have some value, then it is known as labeled graph. If the edges of any graph has some value, then it is known as labeled graph. So the graph you can see here has some values assigned to it. So New York and Boston have 109, and Boston to San Francisco has 378. New York to San Francisco also has 378. So these are the values assigned to this graph. That's why assigned to the edges of this graph. That's why it is known as label graph. Okay.
Ma'am.
Is there any problem?
Yes, ma'am. Ma'am, how a edge have some value? Is it means the distance between New York and Boston or the San Francisco?
I don't understand. Please be a little bit louder.
Ma'am, how a edge have some value, ma'am? I cannot understand that point. Is it means the distance in between New York and Boston or the Francisco?
Yes. So what is the point you don't understand that how an age has some value?
Yes, ma'am.
Okay, say that we are drawing. So this see the bigger picture. Okay. So when they were trying to find out, this is also related to networking also. So when they were trying to draw the network of any mobile phone, they were trying to find out that how we are going to place the towers. We are going to place the towers so that the network can work properly. In a city, there are multiple towers there, right? There is not only one tower, but when they were drawing it very fast, they were drawing the towers, placing the towers in any place, in not any place. So they were keeping some distance. They are making a graph. Say I am placing this tower in Dhanmondi, and this tower I am placing in Uttara. This is in Gulshan. Okay, this is in Motijheel, and this is say in Puran Dhaka. So I am placing the towers here. So and I am finding out what is the distance between these towers. Okay. So when I am placing some towers in these places and I am finding out the distance, so the value between these two connecting lines, which will be connected by the network frequency or network, they are going to be connected by that 1 and 5, they are going to be connected, and say this is Dhanmondi and Uttara are connected, and Uttara and this place I said is say Motijheel is connected, and Motijheel and Gulshan and Puran Dhaka is also connected. So how these things are connected? What is the distance between them? They are connected with a line, say they are connected with the network, and they are between their distance. The distance between them is placed as the value of the age. The age have a particular value that so it is considered in this picture. So this picture is drawn in a way so that you can understand. So
Yes, ma'am. Understand, ma'am.
yes, can you understand now?
Yes, ma'am.
Okay, so this is the distance between New York and Boston. New York and Boston are connected with a road line, and this road distance is 109. So in a way, we can place values. The thing is, we can place values in the edges. So this, if we place values in the edges or give them some labels of values, then they will be considered as label graph. Okay. It has a use in the spanning tree. Those part we are not going to learn in graph. It has a role in spanning tree. labeled graph has a role in spanning tree that used to find out what. So with these values here, we will be able to find out how much time or what is the distance between Boston to this city. I don't know how to pronounce this. So we will be able to find how to go, what is the distance between Boston to this city, and how what is the most efficient roadway to go, or what is the most efficient or smallest distance between these two cities. Okay, we can find that out. So that is the use of this graph. So continuing graph, we have many other things like path. Path is our next idea here. So what is a path? A path in a graph is a sequence of nodes connected by edges. A path in a graph is a sequence of nodes connected by edges. So a path in a graph, there will be a path, as I said for the labeled graph, you can see there, if there can be, if I want to find a path between Boston to this, I don't know how to pronounce this. So how Boston to New York. So what is the path between, or so this city? What is the path between them? Boston to New York, and So let's say this city I to New York and Boston. So this is the path between I to Boston, 109, and I, New York and Boston. So the paths between them are connected by edges. Connected by edges. So you can see there is a graph A here. So there is a path between the nodes that is darkened. You can consider anything as a path. So simply a path is connected lines. A path is a sequence of nodes that are connected. So these are the sequence of nodes. If we had marked them this A, B, C, D, so these are connected with these edges, and we can consider that from A to D we can go through A, B, C, and D. We can say that the path between A to D is A, B, C, D. Okay, so this can be considered as a path. Okay, so what is a simple path? A simple path is the path that does not repeat any node. A simple path is the path that does not repeat any node. Okay, so this can be considered as a simple path because it is not repeating any node. But in case, so say say I am going from, if I want to mark them, how can I write in here? So bear with my horrible drawing because I cannot do better here than this. So this is a path. This is a graph. So if I consider that what is the path will be, what is the path between 1 to 4? What is the way of from 1 to 4? There are several possible ways like 1, 3, and 4 is a path between 1 to 4. There is 1, 2, and 4. There is also 1, 2, 3, 4 can be a path between 1 and 4. Okay. Now, if I say for simple path, we said that in path is a sequence of nodes connected by some edges. Now, if it is not repeating any node in its way, if the sequence of nodes is no node is repeated, then it is known as simple path. So how it is simple path? Let's say what is the root between 1 and 2? What is the root between 1 and 2? So it can be 1, 2, 1 root, or what is the path between 1 and 2? It can be 1, 2, it can be 1, 3, 2, it can be 1, 3, 4, 2, or also it can be, so there is no repeated node. So if I give it like this, it can be 1, 3, 1 and 2. So if I say there are two nodes coming from 1 to 3, so if I say what is the path between 1 to 2, as I said, so for proving that what is not a simple path, if I do this 1, 3 and again 1 and 2, this can also be a path. Just we are going from one place to another. It seems in a sense. So say that I came to my house from your university. So say I came to the university IUBAT and then I came back to my house. Now I was going to say this is my house and this is IUBAT. Okay. Or you can say that I am in IUBAT. Now I am in IUBAT, and after that from IUBAT I am going to go to say Abdullapur. From IUBAT I am going to go to Abdullapur. So I want to find out the route. So while I was in IUBAT, my plan was to go to Abdullapur from IUBAT. But in that place I just forgot something. So say it is in 1 p.m. in the noon. I have forgot something in my house and I have to bring that. So I have went to my house and came back to IUBAT again. And then from here I have moved to Abdullapur. So the thing is, the IUBAT is being repeated. IUBAT is being repeated. So it is not a simple path. So in a path, the values are not, the node values are not going to be repeated. That is known as a simple path. Okay. What was the next topic? So there is connected graph. So if a graph is connected, if each of its nodes, a graph is connected if every two nodes have a path between them. So if every two nodes have a path between them, then a graph is connected. So, so can you see the pictures here, A, B, and C? And can you tell me if they are connected or not? If every two node has a path between them, or every two node is connected, every two node is connected, if a graph is connected if every two nodes have a path between them. So if this, so are these three graphs connected or not?
A and B are connected, but C is not connected.
Why? Why is that?
Because in A and B, every node is connected to each other. In C, there are several nodes, they are not connected to each other.
So let me tell you the definition again. A graph is connected if every two nodes has a path between them. Every two nodes will have a path between them. So that means that there is a path between this node and this one. This node and this one also has a path between them. This node has a path between this one, like we can move from here to here. All of these nodes have a path between them. And same is for C graph. How? To say you can go from this node to this one. How? From here, say A, B, C, D, E, and F. You can move like this. And you can also go from this node to this one. How you can go? So say A, B, C, and D. This is how you can move from here. So in this graph also, each node is connected to each one, or there is a path between each two nodes. Okay. So which
But
is
ma'am,
not
there
connected?
have some node repetition, ma'am.
Yes,
There are node repetition available.
I cannot understand, please.
Ma'am, every two nodes have path, but they have repetition of node also, ma'am. In the previous
That is
picture.
not concern right now. There can be repeated. There can be, no, there is no repetition. As you can see, as I said that from this path to this one from for the tree structure, we are familiar with tree structure. There is no repetition. I can move from this node to this one. There is a path between this node also. I am separately counting. I am separately saying that there is a path between each of the node. I am trying to show you that there is a path between this node also and this node also, this node, and all of them together. There can be repeated because they have not said there must be a simple path between all of these nodes.
Okay,
It
ma'am.
can be
Understand, ma'am.
okay. So what makes a path not makes a graph not connected? You can see there is one city in this graph that is there, only there, but it does not have any degree. That means it does not have any edges. See New York, Boston, San Francisco, and this O city and I city is also there. But New York, Boston, and San Francisco are connected, or they have some path between them. But this node does not have any path between with anyone, does not have any connection with anyone. It does not have any path. So this graph is not connected. It means to say that there is no path between OCT to I or New York or Boston or San Francisco. Okay, but all the other parts have some path. One node of this graph is not connected to or is not does not have any edge. So this is not a connected graph. Rather, we can see all of these nodes, all of the graphs here are connected. Are we clear now? The concept of connection is
Yes, ma'am.
if there is no node without edges, then it is connected graph. If there is edges that if there is any node that does not have any edge, then that graph is not connected. So we are left with many other points here. As you can see, cycle and simple cycle. Okay, so what is cycle? So if we start and end at the same node. Now, as I was saying you from the definition of self loop, if the starting node and ending node of a path is same. So listen here carefully while I said what is self loop. If the starting node and ending node an edge of an edge is same, then that is path. Then that is self loop. Now, while we are talking about cycle, it says if the starting node and ending node of a path is same. Starting node and ending node of a path is same, then that is known as a cycle. Now, starting node and ending node of a path, previously it was the starting node and ending node of an edge. Previously it was that. So, at first we have, if we consider this graph or consider the graph that I have drawn. So let's go to the graph. So it is marked here. If I want to grow, so start and end node will be 1. So what is the cycle here? 1, 2, 4, 3. 1. 1, 2, 4, 3, 1. The path, the starting node and ending node of this path is same. So 1, 2, 3, 1. 1, 2, 3, 1. Okay. So the path that starts from 1 goes to 2, 3, and then comes back again to 1. This is a cycle. This is a cycle. So 1, 2, 4, 3, and 1 can also be a cycle. Also 1, 3, 2, 4, 3, and 1 can also be a cycle. Say 1, 3, 2, 4, 3, and we are going this way, but this is also 3 to 1. This can also be a cycle. The thing is your starting and ending node will be same. So let me write the possible paths here that can be considered. So 1, 2, 4, 3 and 1 can be one path, which is a cycle. Okay, 1, 3, 2, 1 can also be a cycle, or 1, 3, then 3, then 2, then 4, and then 3 again, then 1. It can also be a cycle. Okay, so you have seen the possible paths from that is starting and ending at the same node, which are considered as a cycle, where the starting and ending nodes are same. So what is the reason that I have brought there are several paths, so we can make it any some others also. So 2, 3, 4, 2. This can be a path also. Okay, 2, 3, 4. So this can be a path also, and also 2, say 4, and then 3, and then 1, and then 3 again, and then 2. This can be a path also, right? So you can see there are many paths where the internal values are repeated. Internal nodes are repeated in some paths, and on in all the others one, the first and last node is repeated. Like in this one, you can see the path contains the starting and ending nodes same. Otherwise, all the other nodes are different. In this one, 1, 3, 2, 1, starting and ending node is same, but all the other nodes are different. In this one, C is repeated. In this one, C is repeated. Now, these two cycles are different. So the definition of cycle that I said is that when the starting node and ending node of a path is same, then that is known as a cycle. Now, if there is no, if there is no, if there is no, if there is at least three nodes, if there is at least three nodes and repeats only the first and last node. If there is at least three nodes, you can see there are all of them has three nodes, and it repeats only the first and last node, then that is known as a simple cycle. If there is at least three nodes in the path and only the first and last node is repeated, then that cycle is known as simple cycle. And if apart from the first and last node, other nodes are repeated and there is less than two nodes, like it will not be a path. 1, 3 and 1, it cannot be a cycle or it cannot be a simple cycle. So if the thing is, if the first and last node is repeated and there is at least three nodes in the concern, then it is known as a simple cycle. So it is known as a simple cycle where the first and last node is repeated and there is at least three nodes. That means if anything happens that is other than this, then it will be wrong. Now tell me which one of these all of these nodes are simple and which one of them are not. Is it a simple cycle?
Ma'am, 2 and 4 are simple cycle.
What?
I mean 1, 3, 2, 1, 2, 3, 4, 2. These are simple cycle.
So,
And
let's go one by one. This one is simple.
Yes, ma'am.
first one, no ma'am,
Yes.
first one is not, first one is a cycle, second one is a simple cycle.
So why do you say that first one is not a simple cycle?
Because there is more than three nodes.
One, ma'am, one repeated.
It
First
says
node
that
and
at
last.
least three. That means there can be more. It says that minimum there will be three nodes, but that can be more. No, not all the graphs contain three nodes, but there can be more, but cannot be less.
Okay,
Okay.
ma'am.
So now consider this thing again. Let me tell you the definition again. There will be three nodes, at least three nodes, and no other nodes will be repeated, then the first and last node. Now tell me the graph. Tell me the simple cycle. Is the first one simple cycle?
Yes, ma'am.
Okay. Second one?
Yes, ma'am.
Second one is also simple.
Yes, ma'am.
The third one,
No, ma'am.
so it is not a simple cycle. And why is that?
Because ma'am, 3 repeated.
Because other than the first and last node, there are one more node that is repeated.
Repeated.
This
Yes, ma'am.
one is
Yes, ma'am.
also simple and it is not
No, ma'am.
simple. Okay.
Yes, ma'am.
So this is how we find out if any graph is, if any cycle is simple or not. Now we are left with two more things. One is tree or root. Tree and root. So root is related to tree. So let's at first go with tree. As you can see that this graph is a tree, right? That we can say from our previous knowledge that we have learned so far, we can say that this graph is a tree. So tell me the characteristic that is making this graph a tree, which is not similarly to those. So as this course is going to be, I am going to give analytical questions. So this is an analytical format of the question. I will be giving you these three pictures and I am telling you how this graph is different from the others. Tell me how this graph C is different from the other two.
Well, in the tree, we have to go another nodes of the similar section through the root nodes or through the previous nodes that usually having some repetition, having all the time repetition. But in the A and B, there is usually no repetition. If this is a strongly connected or these have simple code, so that times there have less repetition. But in the tree, there is always some repetition to go one nodes to another nodes of the same section. That is what I actually understand from this picture.
Okay, so you understood, you said what you understood, but this is not the exact essence that differs tree from other graphs. Okay, can anyone say this how it is different? Can anyone see the difference? Okay, let me show it to you. As you can see that the other graphs can have some cycle on them, but tree does not have any cycle. Can if you try it very hard, can you find any cycle? Though you repeat many times, you cannot find any cycle. One node cannot be ending with each because the starting and ending node cannot be same. That makes a cycle. So a tree is a graph containing no cycle. Tree is a graph that contains no cycle. These graphs contain cycle in any way. So if there is any graph that contains no cycle, then that is known as a tree. So you can see that all of these graphs that we have seen so far, they contain like cycles in one way or another. But tree that is separate from all those others that does not have any cycle in it. So this is how it is different from the other graphs. Okay, I will not ask you to differ between graph and tree, or I will not ask you to do differ cycle and tree. I will give you some pictures and the difference you have to find out by yourself. Okay, so practice these things to realize the things that I am asking you. So otherwise you are not going to get to the answer. Okay, so we know so a tree has a root. A tree may contain a specifically designated node that is called a root. We know that the starting node, we call it a root. Okay. Now, what is the directed graph? So the graphs we have seen so far, they did not have any direction. So the direction says from where the graph is starting and where it is ending. So if there are some arrows assigned to a graph, then the graph is known as a directed graph. So there are two examples of a graph is given. of a directed graph is given. There is one here and there is one with names assigned to it. And a graph is directed graph is strongly connected if there is always some directions assigned to the node. If there is always some direction assigned to the node, there is always a direction between two nodes. Okay, so that is known as strongly connected graph. A graph is strongly connected if a directed path connects every two nodes. So we said a graph is connected if there is a node, if there is a path between each two nodes. Now, if we consider this graph, so directed graph, there will be a path, directed path between each two nodes. So is there a path between 1 and 3? Is there is a path between
Yes,
1 and 3?
ma'am. Yes, ma'am.
Directed path. So 1 to 5,
No,
5 to 6, 6 to 3. So there is a path between 1 to 3. So this graph, you can see it can be easily visible that there is a path between each one of the nodes. Okay. Scissors to paper, papers to stone. Then scissors to stone, this is the path. Now scissors to, sorry, scissors to paper, there is a node, and paper to stone, paper to scissors, there is a path between each one of them. So these graphs are strongly connected. Okay, so we have talked about degree, right? We have talked about degree, the number of edges of a node. Now, as there is a direction involved here, there is the degree is divided into two parts. As there is a direction involved here, there is two parts of degree. There are two types of degree. One is in degree. Now, what is this in degree is the incoming nodes, the number of incoming edges. So in the in node A, what are the number of incoming edges? What are the edges at first? So one edge is coming from 2, one edge is going to 2, one edge is going to 5, and another edge is coming from 6. So in degree is number of incoming edges. So how many edges are coming in 1?
two.
There are 2 edges. So this is known as in degree. So there is one more thing, as there is in degree, there is also out degree. So what is out degree? The number of outgoing edges. So for 1, how many edges are going out? There are 2 edges. One is going to 2, another one is going to 5. Okay. With
Ma'am,
this,
we have very less time, ma'am.
I know this is the end of this chapter. This is the end of graph actually only. Yes, any question?
Ma'am,
Yes.
if a circle is drawn in graph, then what will be degree in the circle?
Okay, tell me again. I didn't understand. What type of circle you are talking about?
Any kind of circle in a graph, then what will be the degree represented by the circle?
I don't understand about circle. Circle we have not used. We have used cycle.
ম্যাম
So
আই হ্যাভ কোশ্চেন সার্কেল, মানে আমি বাংলায় বলছি ম্যাম, মানে গ্রাফের মধ্যে যখন আমরা একটা সার্কেল ড্র করি অথবা কোনো সার্কেল যখন ড্র হয় তখন ম্যাম ওটা 3 ডিগ্রি কিভাবে হয়? মানে নরমালি তো বলে যে 3 ডিগ্রি সার্কেল হয়।
সার্কেলটা কোনটা? আপনি সার্কেল কোনটাকে বোঝাচ্ছেন এটা তো বুঝতে হবে। সেলফ লুপের সার্কেলটাকে বোঝাচ্ছেন নাকি?
জি ম্যাম, বুঝতে পারি।
সেলফ লুপে যে সার্কেলটা দেখা যাচ্ছে সেটাকে বোঝাচ্ছেন?
না ম্যাম, না, আসলে মানে নরমালি গ্রাফের মধ্যে নরমালি ম্যাথ করবার সময় যে
নেক্সট ডে ইউ ব্রিং দ্য সার্কেল, ইউ উইল সি। Okay?
And can you please take our attendance? We have another class. Something.
I am taking your attendance. Okay, let's write your names on the chat section, please. It will take less time. Write your names on the chat section, then it will take less time. Name and ID also, obviously.